This time we have NV2, which is the second problem in the node voltage method. So let's start drawing the circuit. This is NV2, node voltage second problem. So what we have is a resistor way on the top. Then we have a voltage source, minus here, plus here, piece of S. While at it, let me also write the 1 ohm resistor on the top. Then we have an inductor hooked up in this manner. We have a current source IS. Let's see what's going on here. This inductor is connected here, which is grounded, and this inductance is 0.05 Henry. Okay, here is a resistor in an amount of 2 ohm. Then there is a diamond, which is a dependent source. This one has plus and minus 20 I naught, where I naught is the current flowing through this inductor. Okay, and we have another resistor here of resistance 1/2 ohm. This 1 ohm is coming all the way here, and then we have a capacitor here connected as well. So this capacitance is 2 farad. We're almost done with the circuit drawing. So let's go back. We have the reference node right here. Then node number 1 is here. Node number 2 is here. In between, we have the source piece of S stuck. Then we have node number 3 right here. Between node 2 and 3, we have 2 ohm resistor. Next, we have node number 4 here. And on the top, we have 1 ohm resistor running all the way. So we have this diamond, which is a current dependent voltage source. The current is I naught, which is multiplied by 20, as diamond produces the voltage as the output. So the task here is to come up with a matrix as always, and we will use KCL because we're using node voltage method primarily. So let's remember the relationships. I sub C, current passing through a capacitor, is given by capacitance, and this is the differentiation operator, P sub C. And using Faraday's law, we can get I sub L, which is the current passing through an inductor. L is 1 over L, the inverse of D, which is D minus 1. So it is the inverse of differentiation. So namely, it is integration, D sub L. So we will use this relationship. Now we have to combine the nodes 1 and 2 to make a supernode. But why is that? Because in node voltage method, we are checking the current along all these wires connected to a node. So if we do that to either node 1 and 2, we have a voltage source on its path and the wires, and there is no way to tell how much current is flowing. So to not get in that situation, we will consider nodes 1 and 2 as supernode. So let's go ahead and write supernode consisting of node number 1 and 2. So what have we here? Node 2 is on the plus side and node 1 is on the minus side. In between we have p sub s, meaning p sub 2 minus p sub 1 is p sub s. So we have a box here which we can put in the matrix later. So let's draw this box. So this one has, let's say, minus 1 with the v sub 1, and it has 1 with v sub 2 multiplying it, that is, and no v sub 3, no v sub 4 equals p sub s. So this is ready to go to the matrix. Next, let's consider what is I naught. Notice I naught is the current that is flowing through the inductor. So I sub 0 or I naught is 1 over L. L is the inductance. Here we have this L being 0.05 Henry. So 1 over 0.05. Then we have what now? The D minus 1 operator and the voltage between node number 2 and the ground is V sub 2. So V sub 2. So that will be 20, okay, 20 D minus 1 V sub 2. So why do we need this I naught? This is to get the output from the diamond. Diamonds are mystic. They have quantities like 20 times I naught. So the first thing we would do is demystify the diamond, get its bit. Meaning 20 times I naught is now simply 20 times the value of I naught, namely 20 D minus 1 V2. 20 times 20 is 400. So D minus 1 V sub 2. So we will be using this expression at some point later. So let's just remember that we got this, which is primarily the voltage V3. Okay, so this is V3. What that means is we actually have V3 minus 400 D minus 1 V sub 2 equals 0. Now guess what? This is ready to go to a box. So this will give us another box. So that will have no v sub 1 and what now? Plus minus 400 D minus 1 with v sub 2, then 1 v sub 3, no v sub 4 equals 0. So this is ready. Next, we will consider the supernode we talked about, namely supernode 1 and 2, and apply KCL. So KCL as applied to the supernode, which is node number 1 and 2, we have 1, 2, 3, 4 legs connected to this supernode. I sub s is going to the supernode. So using passive sign convention, we have minus is. What else? Then we also have the current flowing through the inductor 0.05, which is I naught. And so we could also write this thing as I naught, or simply 1 over 0.05 as we did before actually, d minus 1 p sub 2, which is 20 d minus 1 p sub 2. We're going to write that just a little bit later. Now, current is also flowing from the node number 2 to node number 3 through the 2 ohm resistor, and that will be p sub 2 minus p sub 3 over 2. And from 1 to 4, we're using house rules, so whichever node we're considering, that node is at the top. So p1 minus p sub 4 divided by what now? 1 equals 0. So we will simplify this expression, giving us minus is. Okay. Then we have plus 20 d minus 1 p sub 2. Next, plus 1/2 p sub 2 minus 1/2 p sub 3, then plus p sub 1 minus p sub 4 equals 0. Okay, so we will simplify this or make it ready to go to the box, so we can put that in the matrix, meaning this has got 1 p sub 1 plus 20 d minus 1 plus 1/2 times p sub 2 plus minus 1/2 p sub 3 plus minus 1 p sub 4 equals is. Okay, so we have 1, 2, 3 boxes already formed. So the last one we will get by getting the KCL, shall I say, at node number 4. So at node number 4 we have 1, 2, 3 branches. So from v sub 4 to v sub 1, in house rule, v sub 4 minus v sub 1 over 1 is the current flowing that direction. V sub 4 to v sub 3, through the resistor of 1/2 ohm, we have v sub 4 minus v sub 3 over 1/2. Okay, and we have through the capacitor 2 farad using I sub c c dVc, we have 2 d v sub 4 equals 0. So let's simplify this fellow, which is v sub 4 minus v sub 1. Flipping the 1/2, 2 goes to the top, 2 times v sub 4 minus 2 times v sub 3, then plus 2d v sub 4 equals 0. Or we can write this as minus v sub 1 plus 2 and 1, that's a 3 v sub 4 minus 2v3 plus 2d v sub 4 equals 0. So let's put this in the box as well. So what have we here? Minus 1 v sub 1. There is no v sub 2. Then we have minus 2 v sub 3. Then we have 2d, what now? Plus 3 v sub 4 equals 0. So this is the last box we need to fill our matrix. Wait a minute, this is connected here. Okay. So our matrix will look like minus 1, 1, 0, 0. Let's draw this fellow here. Oops. V sub 1, let's go ahead and do the other fellows too. V sub 2 and V sub 3 and V sub 4 equals, okay, I'm going to draw this thing here. The source vector on the right side. Well, on the top we will have what now? V sub s. Okay. Next we have 0 minus 400 d minus 1, 1, 0. That will be 0. Next, we will have 1, 20 d minus 1 plus 1/2 minus 1/2 minus 1. That will be here on the right side I sub s. Finally, minus 1, 0. This is 0. Minus 2, 2d plus 3. Wait a minute, this is not looking good. Let me clean this thing up. So this is 0, and this pillow is a little dirty. Okay, that's 2d. This looks like 20. Okay, I will try a little carefully. 2d plus 3. How about that? That's better. 0. So this will complete figuring out the matrix. Hope you enjoyed. That's about it for now. Take care.